In the previous video, I talked about the compression, what caused a compression, and in the one before that I talked about what caused the function to stretch. So a stretch, if you stretch something out, it gets skinny, which happened here, and a compression is when you push something down so it squashes out, it presses out. Okay? So that happened when I was multiplying a value in front of the absolute value sign. So let's go back to this chart. And so what we had looked at was this A, this number here in front. So when I was multiplying by some value, it either did a stretch or a compression. So notice that this is, I'm multiplying on the outside of the absolute value. Oops. And if I had a number, if A was greater than 1, which we notice with the number 2. So when I look back over at here, when this is bigger than a number 1, it gave me a stretch by 2. So if the value of A is bigger than 1, I get a stretch. And if it's a number between 0 and 1, I get a compression. Okay, so if it's between 0 and 1, I get a compression, which we saw here. 1/2 is between 0 and 1, and it drew a compression. Today, we're going to look at this thing called a reflection. So there's a number of things that can happen all at one time. We're just looking at them one by one. So again, our parent function is f at x equals the absolute value of x, because we're dealing with an absolute value function here. So what do you notice that's being multiplied to the front of the absolute value? Well, we have this, I don't want to use that blue, it's too dark. We have this negative sign that's being multiplied in front of the absolute value. Well, that's the same thing as the absolute value, excuse me, that's the same thing as -1 times the absolute value. Those are the same thing. When I look inside the absolute value, nothing is being added or subtracted. So that means that nothing is being added or subtracted from that x. When I look outside the absolute value, nothing is being added or subtracted to the x. So that means then that my vertex is 0, 0, because I get it from this value here is my x, this value here is my y of my vertex. Okay. So here I get my axis of symmetry. So the x value of my vertex is my axis of symmetry. So here my axis of symmetry is 0. Okay. So transformation, what happened? Well, I don't know yet. It didn't go left or right, and it didn't go up or down. But this -1 is probably doing something to it. So let's see what happens. So let's again go to our calculator. Instead of 1/2, let's go ahead and, actually I'm just going to clear the whole thing out. Go ahead and do negative, which is the same as -1. So we're going to do negative, and I'm going to do number absolute value of x. So when you do this, make sure you push this button as negative. If you push this button as minus, the calculator will give you an error. So I go ahead and graph it, oh my, it flipped. It actually went from being on top in a positive direction, and it did a reflection. Okay, it's like looking in the lake. It did a reflection of the image, and we can see that here. So I'm just going to write that down. The transformation is a reflection. And what axis did it flip over? It flipped over my x-axis. So it's reflection over the x-axis. Okay? There is a reflection over the y-axis, but we're not going to study that. So if I were to go in and I can look at my table and I can put in my values, then I could go ahead and graph my transformed function. I'm just doing this real quickly. You can look at the table and it will show you it's just the points going down. So I'm going to go ahead and I'm going to, so if you're not clear what I did here, go back and plot those points in your calculator. I just don't want to spend time plotting points. So this here goes down. Okay, so remember, this one here, this was my parent function, and this was a function of negative absolute value of x. My vertex is right here. That's my vertex, and that's at 0, 0. And I also had an axis of symmetry, which also happened to be here. So I've done quite a few examples where the axis of symmetry is the same as the y-axis. That is simply coincidence. It is not always that. So we'll see in the next video that I'm going to do, we're going to put all these together, and you're going to see that the axis of symmetry is very dependent on where that vertex is. So the axis of symmetry in this case is the line x equals 0. You always express the axis of symmetry as an equation.